Okay. Right. So tonight we'll be talking about OSPF, Open Shorted Passwords. It's a routing protocol, a popular routing protocol. It's also open standard, and then many are implemented in ISP networks. Okay, so here are the agenda. First, we'll do a review about routing. So hope you don't feel bored with this. I feel this is important because many troubleshooting requires basic and strong understanding of how routing works. And then we're talking about interior and exterior routing, about OSPF, talking about OSPF, and then do some configuration for OSPF and then live practice. Right, so about GLC, we are an organization based in Bandung. Our areas are IT training and consulting. We also do some programming, and then we have our own product called GLC Radius Manager. Also includes the billing stuff inside. We are partners for Macrotic, Ubiquiti, and Linux. We also have regular events like what we are doing tonight, especially for the webinar. My name is Achmad Mardiansyah, and I'll be the speaker for the webinar tonight. Based in Bandung, I'm Linux user since 1999. Microtik since 2007. Ubiquiti and Microtik, and Linux enthusiast. If you have LinkedIn, we can get connected there. Also write some articles in several websites. Past experiences. Here we support some projects in overseas, especially related to ISPs. Okay, like setting up, doing migrations like from bridge to routed network, integrating the radius to the network so that we can control only customer is paying that can connect to the network, which is important for the business, right? Okay, and also setting up wireless infrastructure projects in some places. About the webinar itself, we started webinar since 2010 with various topics, and you are feel free to join the webinar as well as a speaker. So the purpose for the webinar is to share the knowledge and sharing experience among engineers. So from engineers to engineers, or from engineers to others. Okay. So thank you for introduce yourself in the group chat. So I can see some of you are from Indonesia and some of you are not from Indonesia, from overseas, right? And okay, let's talk about the routing basics here. So as we know, when we talk about the communications, we split the communications into layers. We have 7 layers based on the OC perspective, OC organizations, that we have layer 2 and layer 3. And then in this layer, mainly focusing on different purpose. So layer 3 is focusing on end-to-end communications, while the layer 2 is for adjacent communication here. So that's the big difference between these 2 layers, okay? So layer 2 is written in a hexadecimal format. It's burn-in address, so it's very physical, but we can change it later, you know, that software can do it, right? While in layer 3, it's end-to-end There are two versions, IPv4 and IPv6. Okay, so previously it was full IP address. Okay, so here it is. Okay, and it was done long time ago in early before early 90s, so in 80s. Nobody expect the IP protocols become very popular in the world, so they just they just use the IP address generously. Okay, never care about, oh, okay, we'll be running out the IP address later, so they never thought like that. After IP address is become very popular, internet has become more and more affordable for many people. In the beginning of 1990s, there's an RFC to do the classless IP address. So it means that we don't use class, okay? So we don't have any class. So please guys, if you are teaching in networking, please do not say class A, class B, class C, because we don't use them anymore, okay? We use VLSM. So every time we put an IP address, we have to put a slash something, slash 24 or slash 25 or slash 26 or whatever. Okay, so that is mandatory, where mandatory settings when you set up an IP address. Okay, because we use VLSM, and then we will use CIDR, classless interdomain routing. Right. So next. Yeah, so this is IP specification based on RFC 791. It was a long time ago. So actually the technology that we are using today, it was very old technology. Okay, next year is gonna be 40 years, you know. See, this technology was written in 1981. Okay, next year is 2021. So you can see on layer 2, we already have coaxial based Ethernet, and then we have a high speed internet, which is 10 Mbps. I still remember I still do a crimping tool with the hub in late 90s. So I learned networking in the late 90s. At the time we use a coaxial cable for communication. Yeah, and then the technology keeps evolving, keeps improving. So from 10 Mbps becomes 100 Mbps, and now it's 1 gigabit per second. But it was done in layer 2. So there are lots of changing in layer 2, becomes more and more faster. The capacity is keeping higher and higher. But in the layer 3, which is the internet layer, we just use the same technology that was born in 1981. Well, there is a new version called IPv6 here, yeah. But the problem is not so many adoption for IPv6. Why? Probably because of the economical business reason. Because previously, if you compare to, we have 3G, 4G, 5G, 6G, whatever G, when you put that into your network, and then there will be an improvement regarding with the speed, right? And then people are happy, and then yeah, you can make more money. But if you implement only IPv6, okay, is there any faster? No, not really. Is there any improvement regarding with the application? Well, some. Obvious benefit if you use IPv6 is because you don't have to put NAT, because the address space is very, very large. Okay, instead of 32 bits, like what we have here, it was 32 bit for the IP address. For IPv6, it has 128 bits, so 4 times larger. So back to the IPv6, okay. Some application, they don't support IPv6. So it's kind of, it's kind of challenging whether people wants to implement IPv6 or not, okay. But eventually IPv6 is the default, but the adoption for IPv6 is very, very slow. Okay, next. about the layer 3 itself. So as we know, IPv4 is 32-bit long. It's written in binary. It has two parts, network part and host parts. See, so it's similar to the like a phone number, a mobile phone number. If you see, if you have a phone number and then the first maybe 3 or 4 digits is belongs to an operators. Okay, and then the rest is the host part. So if you are in the same network, usually the first 4 digits are similar, like what we see here. Okay, so when you write an IP address, for example, this one, okay, so it means that you have to split them. For example, this side is for network, and then this side is for host. Okay. So, and then you can calculate subnet mask, network ID, and then broadcast ID using the AND and operation. Okay. If you learn programming, there is a bitwise operation, and then one of them is AND and operation. So it's like a 1 and 1 equals to 1, 0 and 1 equals to 0. Okay, so like a true and false equals to false. Right, so we don't talk, I would assume you already know about the routing basics, so I just do the review. So hopefully by understanding the how the routing works, the routing basic works, and then you can get better understanding about how OSPF works. So about the VLSM, this is the RFC. Again, the RFC was done long time ago. See, it was done in 1995. So, so class A, class B, class C is not used after this year. Okay, so yeah, 1995. So after this year, and then all routers will do the routing based on the subnet mask, as we call it CIDR. Okay, so this is the another RFC for CIDR. So it means that we will do routing based on the based on the classless interdomain routing. It was done in 1993. Okay, so it means that when you do a routing, as you can see here, we don't put the class A, class B, class C. So as you can see, put here a slash. So it's mandatory to have a slash, like a slash 19, slash 18, slash 24, and so on and so forth, right? Okay, so it was the CIDR. So please guys, if you are teaching networking, please inform your students that we don't use class anymore, okay? And here's the proof, okay, the RFC. And then we talk about router and routing. Router is the device, okay? Routing is the process to select a best path from source to the destination. Okay, so we have router and routing. So this is the router, physical router here. Okay, and here's the icon. Okay, so why the icon is round here, as you can see, while physical is looks like a box. Well, it's just an icon. Okay, so this is IPv4 header, and this is IPv6 header. So as you can see, the address space here is very long compared to the IPv4 on the left. Okay, so we are forwarding packets both based on this header information. So this is the header for IPv4 here, and this is the header of IPv6. Okay, so when you send something, there will be a header that is added in front of the data that you are sending. Okay. So this is a typical connection. So so you have routers, and then router connects to layer 2 segments. So blue here means the router, okay? While the red here is the layer 2 segment. So we have a router. Oops, perhaps I can use others. Okay, green. So this is the router. We have 3 routers here. Okay, and then these 3 routers is always connected to layer 2 segment. Okay, so we have a layer 2 segment here, another segment here, another segment here. Okay, maybe different colors. Okay, another segment here, another segment here, another segment here. So this is how a typical network looks like. So layer 3 always is connected by layer 2. So it's always a connection between layer 2 and 3 and 2 and 3 and 2 and 3 and so on and so forth. So this connection is keeps um, uh, gets connected like that from source to the destination. Okay, so it's a combination between layer 2 and 3, 2 and 3, 2 and 3 until it reaches destination. And then inside the routers, we have routing tables. So this is how the routing tables looks like. Okay, so in every routers, this is the routers. Oops. Okay, so this is the routers, and then inside this router, we have a routing table like this. So which showing you that if I want to go to a certain destination, this is the gateway that I need to go. Okay, so this is the router 1. Router 1 has adjacent router, so it can forward the packets to router 3 or router 2. Okay. So in every router, you will see there is routing tables, and then inside the routing tables, you have routing entries. Okay, so this is an example. So if I want to go to a certain destination, there will be a way how to forward the packets based on the destination address. Okay, so this is, for example, before we are forwarding the packets, we need to rearrange the sequence. Okay, so when we have a table like this, the rule for the routing table is the longest prefix wins, the lower distance wins. Okay, so it shows you the priority, how to process the rules. The routing table processing the entries like a firewall, match, and then action. Okay, so this is the match. Okay, matching the destination, and then action is forwarding the packets to the gateway. Okay, so how do we set up a priority? By checking the prefix. So here the prefix is 32, and here is 26, 34, 24, 24, and then here is the last resort, aka default gateway. So so default gateway actually is the lowest priority, not because, oh, well, that's default, right? So it has to be put in number 1. No, it's not. Actually, default gateway is the last resort. Okay. The longest the prefix, that's the highest priority. Okay. So for example, here, packets arrive at router 1. Here's the destination. Here's the routing table. Okay. Okay, and then here's the packet, and then the packet has a destination of 192.168.2.6. Okay, and then if we convert it to binary, we'll be checking like this. It will be, yeah, it be looks like this, the binary 110 whatever, and then first you need to check the first entry. Does it match on the first 32 bits? Because this one is 32 bits, but unfortunately it's not, right? So you can see the difference here, okay? And then check, because this one doesn't match, we go for the second entry, then check the first 26 bits. Okay, is it match? No, it's not. Okay, and then the third, and then fourth, Okay, so 4 is okay. So we go this one so that the packet will be forwarded to this gateway. Right, so that's how it works. Okay, the routing table in MikroTik happens in the routing decision. So it means that after packets arrive, and then on the firewall, there will be a pre-routing processing here, and then we have a routing decision. So after reading the routing decision, IP/IP route print, and then there will be a two decision whether to forward to input. It means that the destination is the router itself, or we can forward them. Okay, forward to the other interface or the same interface. So it means that packet is just passing the routers, not end up at the router itself. Okay, so that's for incoming. For outgoing, so the package that is generated by the router itself, for example, replying a ping, or you want to ping something from the router itself, the routing decisions is done after the local process here. So local process like Winbox, the service that is available on the router that is consumed by others external. Okay. Look, if you have a question, and then please type something. Okay. Other analogies like this with administrative distance. So if you want to go somewhere, and then here's the examples. Okay, so here are the list of the cities. Okay, if you want to go city number 2, you have two options. You can go straight or go left. Okay, but other consideration is the distance here. Okay, and then we convert the analogy to the routing table. So where you want to go, here's the gateway, and then here's the distance. This is gateway, and this is the DST. So we only do routing based on the destination address. Okay, and then from here we convert into the routing table. So IP route print, and then here's the results. So same thing. This block is for destination. This column is for gateway, and then this column is for distance. Okay, so again, from here to here, next table, from the table to the real table from the routers. About the administrative distance itself is considered as a distance. So it seems like a real distance. So if you want to go from A to B, and then you always pick a path that has the lowest distance, right? So similar to administrative distance for the routing. So the administrative distance only applies on particular routers. Okay, other routers also will do the same. So one router will not do administrative distance, will not affect administrative distance on other routers. So every router is independent to set up their own administrative distance. And then, it's based on convention. For example, external BGP is 20. Depends on the convention agreements between vendors or a community. Again, internet is based on a community, and then in this community we set up the administrative distance of every routing protocol like that. Yeah. So OSPF here, administrative distance is 110. Again, for the static routing, we can set up an entry in our routing table. So we set up the destination address and then the gateway to reach that destination address. Okay, so this entry, okay, is done manually. So that is the meaning of static routing. Okay, so this entry is done manually by admin. Okay, so admin has to go to log into router 1, admin log into router 2, log into router 3, and then on each router, admin needs to create the routing table. Yeah, it's a tedious task, but that's how the static routing works. Okay. Okay, next is autonomous system. So autonomous system is a collection of routers and networks under one administration and apply a single routing policy. So AS number is identified by a number, AS autonomous system, given by RIR, or regional internet registers like EPINIC, ARIN. EPINIC is for Asia Pacific. ARIN is for North America, USA and Canada. RIPE NCC is for Europe. AFRINIC is for Africa, LACNIC is for Latin America. So this is how it works. Okay, so every router that belongs to an AS number must have a AS number. Okay, so there will be a border router here. Okay, better use different color. So this is the border router. Okay, so it's the router that connects to other router. Yeah. Okay, so there will be, so inside the one AS, there will be several protocols that runs together, usually BGP and OSPF. We're not talking about BGP today because it was is already discussed in the previous webinar. Maybe in the future we will discuss another BGP again. Yeah. Yeah, so there will be, when we run routing protocol, there will be parameters in the routing protocols that deals with the scope and target scope. Okay, because we want to do recursive routing, a recursive lookup for routing tables. Okay, so it means that for example, in one router here, I'm running OSPF, BGP, and then OSPF. So both are running on in the same router. Is it okay? Yeah, that's fine. So how to distinguish them? By administrative distance. So when we, in the previous slides, as you can see, they have different distance, right? So it means that we can use them to identify which one is OSPF and which one is BGP. So this is OSPF and this is the BGP. Internal BGP is 200, external BGP is 20. Okay, so important to note, routing is done only one way. So from A to B here, okay, so this is A and this is B. From A to B can be this path, but from B to A can be like this. Okay, different path. So there is no guarantee incoming path is similar to the outgoing path. So what we control is only outbound traffic. Yeah, why? Because that's our routers, right? When we have incoming, and then the incoming traffic is generated by is going through the different router, which is not belong to ours. Okay, so again, we can only steer the traffic on the routers that we are managing, and then usually for outgoing path. Right. So next. Interior and exterior routing. So as we know, we already have AS, and then AS, inside AS, we have several routers. Okay. And then the routers that connect to other AS is called border router. So we have border router here, border router here, border router, border router, border router. Okay. So between this border router, you can see it's a BGP. Okay. It's BGP. So the green color here is the BGP. What about the blue one? That is for internal uh, internal AS. Okay, and then for the internal AS, we usually use OSPF. Okay, so between AS it's BGP, internal AS here. Okay, it's OSPF. So two protocols at the same time. Okay, let's. Oh, okay. I have a question here. What's the difference between OSPF and BGP? Well, I have just explained it already. So BGP is for inter-AS routing exchange. Okay. What can be used for internal AS? Okay. But OSPF is mainly for intra-AS, so internal AS. Okay. So that's the, hopefully you can understand that. So how OSPF works? Well, what is OSPF? OSPF is dynamic routing protocols. It's a link state with Dijkstra algorithm. It has hierarchical routings using area. And then it's IGP, interior gateway protocol. So all routers must have a same AS number. And it uses a protocol number 89 used by million organizations, support load balancing. Drawbacks, I don't think this is a drawback. It has a CPU intensive, especially if you have a change on your network. Because why not drawback? Because CPU power in the router now is very, very powerful. So we don't have to worry about how OSPF will give additional load for router performance. Another is more complex compared to RIP, of course, yes, because there are so many parameters in OSPF. Okay, so let's talk about the area. Yeah. So in OSPF, so there will be a routers. Yeah, this is routers. The router has to be in the same area. So there will be, the concept has to be in area 0. And then this area 0 will connect to other areas. For example, this or this. This is area 1, area 2, area 3. So there will be an area in the middle where other areas can connect. So area 1 cannot connect to area 2 directly. So it's not allowed. Okay. So area 1, if they want to send something to area 2, they have to go to the area 0, through area 0. So that's why it's called area 0 or backbone area. So backbone area is an area where traffic is flowing. Okay, it's not allowed to send directly data from area 1 to area 3 directly. No, it's not allowed. Okay, so this is not allowed. If area 1 to send, if area 1 wants to send data to area 3, it must go through the backbone area and then go to area 3. So there is no direct connection between this area. Yes, there is a possibility to send the the traffic, but it will be considered as a backbone here, right? So if they want to send connect, so it means that only the backbone area is the place where the traffic is exchanged between areas. I mean, non-zero areas. Okay, so that's why it's called hierarchical routing. So it's like a hierarchy. So everything must go through area 0 first and then to go to other place. What about the BGP? Yeah, BGP router located in area 0. Right. Can OSPF be used on peer-to-peer networks? Well, I think it's two different things here. Okay, OSPF is a routing protocol running by the routers. Okay, so you have routers, and then these routers communicate to each other. Okay, routers communicate to each other, and then the protocol that are that they use is OSPF. Okay, so it's just two different things. So it's like comparing between uh, can can um, can a car be used in the clothes? So it's two different things, yeah. Car and clothes. Clothes means clothes, yeah. T-shirts. It's two different things. Okay, peer-to-peer and OSPF is two different things. So peer-to-peer is uh, is uh, is alternative of a client server. Okay, so we have architecture of application. We have a client, and then we have a server. For example, HTTP. So you have a HTTP server, and then you have HTTP client as a browser, okay, aka browser. For the server, you have Apache, Nginx, IIS, other web servers. There are many web server software out there. Okay, yeah, so it's two different things. So as an alternative of client server architecture, we have peer-to-peer. Okay, so peer-to-peer is there is no client, there is no server. So between them, it is in the same level. They have a same level. Okay, they are exchanging something. Usually is the files or informations. Right. So that was the OSPF. Some terminologies. We have a neighbor, adjacency, a link, a router ID, link state, cost. Well, actually, I just realized that there are so many slides here that is discussed for 1 hour. But never mind. Okay, so okay, so my proposal is at least when you go to this webinar, at least you must have a basics. Okay, so I just go through and then yeah, hopefully you can follow some materials here. Oh, okay, another question. So SPF is built in automatically in the routers. Well, depends on the routers. Some routers support OSPF, some router don't, but many routers now supports OSPF. I never see, except your own routers. uh, I think OSPF is one de facto routing protocol that is supported by many routers. So if you buy Juniper, if you buy MikroTik, if you buy Cisco, if you buy routers from other vendors, they support OSPF. Okay. So the router type in OSPF networks. So as I said before, so this is an area, right? So for example, this is another AS, and this is your AS. Okay, and then here we have ASBR. It means that the border router here. Okay, the ASBR is this. And then we have inside the area, We have a small area, for example, area 1, area 2, area 3, okay? And then from area 0 to area 1, there'll be a router that connects between the area, and then that router is called ABR. Here, that's the ABR. And inside the router, inside the area here, is called the internal routers. Here, okay. So another question. So in your opinion, is it easier to handle routing between internal router with OSPF than BGP? Even like a connection between distribution router to the border router. Sorry, I don't understand. It's easier to handle routing between internal router with OSPF than BGP. Oh yeah, yeah. Well, you can use BGP internally. Yes, yes, as an internal. So you can you use BGP for all in your routers. Yes, it's possible. Yeah, inside your AS number. Yes, but for internal AS, we use other routing protocols like OSPF or RIP or any other routing protocols. Okay, so it is easier. Well, I don't think it's easier. That depends on your knowledge. If you already understand what you're doing, it's easier. Yes, I guarantee. Okay, so if you don't have the knowledge, and then yeah, just say goodbye. Okay, so that's the how OSPF works. Okay, but in the reality, not all networks has area 0, area 1, area 2, area 3. Sometimes I have 14 routers, and then all of them are in area 0. Well, that's fine. Okay, we don't have to split them into areas. Okay, next is OSPF cost. So when we determine the path, OSPF use cost to determine the path. For example, for this is source. This is the source, and then here's the destination, right? We have two paths. This is the first path, okay? And then here's the second path. Okay, so which path do we use? Well, that depends on the cost. So cost is assigned per interface, and then it's accumulated from the source to destination for that path. Okay, so we are just summarize the cost here, okay, and then compare the two. So here total cost is 49, here is 40. So in this settings, in this configurations, we'll use the upper path yeah, to be used as a best routing path. All right. Okay, so I have another question from Peter. Can we use switch to replace router in the network? Well, switch is layer 2, router is layer 3. Okay, so if you don't want to, because if you want to have a simple network, yes, you can use switch. Okay, but the drawback for the switch is you have a flat network, and if something happens, for example, if one host is infected by virus, and then in the same segment, it can broadcast to others, to other hosts, and then that makes the whole networks become really slow. Okay, so can we use switch to replace network? Yes, if you want to have a flat network, yes, it's possible. About the configuration itself, so if you want to configure the OSPF, we recommend you to set up a bridge, a loop back here. So we set up a bridge. We create a bridge named loopback, okay? Yeah, and then we assign the IP address and the loopback. And then we add interface, OSPF interface. And then we set up the router ID, okay? And then the network. Yeah, so in this case, I put 3 networks here. So actually this part is important. Okay, important part to add the networks. If you add the network, and then usually the interface is added automatically. Okay. Oh, okay, so it's time to practice. Well, I will share the SSH username and password. So, okay, please be ready there. Okay, I've shared the address, and then let me share the whole screen. So hopefully you can see that. Okay, so I'm checking the I'm logging into the live server. Okay, let me check here. Okay, I'm logging in as live 20. Okay, so I'm in. Okay, looks like nobody joined me. Okay. So I have, oh, okay. So I need to turn on the servers, the routers, I mean. So, okay, let's start 5 routers. Okay, inside here. And then I will test the 241. So ping netsim 241.lan.glc networks.com. Okay, it's there. And then what you can do is to log into one of the routers. Okay, so I need to turn on another router here. Okay, it's there, done. So I will do SSH. Here I'm logging as an admin. And then you can use ports 2201. So 220X. Yes, X is the router number. So you can use either X equals to 1, 2, 3, 4, 5. Or you can use, no, you cannot use telnet. See 2001. Yes. Okay, I'm in. Okay. So IP address print. Okay, only one IP address. Okay, let's check interface bridge print. Okay, it's not there. So we can add a new bridge, name loopback. Okay. So I will add, so IP interface print. Okay, so it's loopback is there. And then I will need to address, I will need an address to that loopback address. So IP address at, right, interface loopback address 192.168.0.x, okay, /32. Okay, so X, because I'm router 1, X equals to 1. And then here we go. Okay, so on Ether 6, let's do how to connect to MikroTik. Well, so you have to log in first. Okay, I'll do exit. Okay, /exit. What's the command to quit? Quit? Ah, yes, quit. So if you want to log into MikroTik, we have 4 MikroTiks, and we have 5 MikroTiks here. Okay, and then we can connect through Ether 6. Okay, Ether 6. So you can, after you log in to a live service, live practice, and then you can do SSH admin, and then here, and then with the different ports. Okay, the port number is this 2201 is for router 1, 2202 for router 2, 03, 04, 05. Okay, only 5 router available in this practice for this practice. Okay, so I just only have one. Oops, I only. Oops. Oh, sorry. I'm confused between Linux and MikroTik here. Sorry. So IP address print. Okay, so Ether 1 and then loopback. So we need to put IP address. So another IP address, we add another IP address on Ether 6. Ether 6, okay. And then the IP address is 86.x, okay. And then the netmask is 24, for example. Yeah, so IP address print. Okay, here it is. So we can set up the next router, for example. So I'm logging into the SSH admin at netsim 241.lan.glc networks.com -p2202, for example. Oops, typo. Okay, we will stop late. That's fine. If you have we really need your feedback. Okay, so admin already share our feedback there. For those who still wants to join me for the live practice, feel free to join. Okay, so I'm here configuring router 2. Okay, so I'll be interface bridge print. So I'll be adding another loopback interface here. Okay, and then add IP address /IP address add right interface loopback. Okay, address 192.168.0.2/32. Right. Okay. And then I will add another IP address on Ether 6. Okay. 86.2/24. So it means that on router 1 and router 2, so as you can see, we have IP addresses here. And then on router 2, we have another IP addresses also here. So it means that they can ping each other. Okay, let's try 192.168.86.1. Okay, done. Now we will set up the OSPF / routing OSPF instance print. Okay, so we can set up our router ID here. It's similar to the one that is assigned to the loopback 0.2. Okay. Oops. Default, yeah, sorry, I forgot this one. Okay, done. And then when I see the router ID is already changed. Okay, so the same command, I will apply it on router 1. Okay, copy and paste and then modify, don't forget. Done. Next step is add the network. Okay, routing OSPF network add. Okay, area is backbone. Network is okay. I will advertise. So it means that we are advertising our network. So the network that is connected to us, for example, network in loopback and network in Ether 6. So 192.168.86.0/24. That's the first network. And the second network is 0.1/32. Okay, we can display here our network. Okay, so we already advertised 2 networks. Okay, that's good. And then the same also will be applied here. Okay, so we advertise the router ID. Sorry, the Ether 6 and then the router ID. Done. And then we check. Okay, both of them already advertised. Okay, in router 1 and router 2. Okay. And then we check IP route print. Okay, we also check in here. Did I forget something? As you can see, I got a prefix here from the router 2. So you can see O here, small o, it means that comes from OSPF. Right. Okay, so they are in adjacency now. Okay, so both router can see the loopback for adjacent routers, and then yeah, they can exchange the routing tables. Okay, guys, so that's how the OSPF works. Really, really easy. I mean, yeah, for the more details, you can join our training there will be topics that will be discussed deeper compared to what we have now. So this is just an introduction for OSPF. At least you have an understanding about how OSPF works. Okay. So a simple OSPF like this, where we exchange our loopback IP address with OSPF. All right, so thank you very much. Anything else from admin? From moderators? Hello? Okay, you are welcome. Hernan. Right, so guys, thank you very much for coming. Anything else from admin? Hello, admin. Are you there?
Hello?
Yes, we can hear you.
Yes. Okay. Yeah, thank you. Thank you for all attendance here. We hope this webinar will give you a good benefits. And from Pakistan, Bangladesh, and especially from Malaysia, 2 thumbs up for you all. Thank you very much. And the last request, please turn on your video, then we can take a picture together.
Oh yeah, guys. So it's a photo session.
Last request for everybody.
Okay, so we have a request here
Thank you
from
so much.
admin
Yeah.
to turn on our web camera. Right, so this is me. So thank you for joining. Hello, admin. Can you see?
Yes, I can see everything. Everyone. Can you
Great.
take picture?
I want to take pictures. Right. Okay, anyone?
Smile, please.
Smile. Okay, so
Done.
okay, let me take a picture. 1, 2, and 3. Off we
Smile.
go. Smile. Okay, thumbs up. 1, 2, and 3. Yeah.
All right.
All right, guys. Thank you very
Thank you so
much.
much, guys. Don't
Yeah.
forget to put the feedback, please. And
Oh
then
yeah,
if you
for the
have
feedback.
any idea for the next webinar, please just
Yeah,
mention that.
the next topics. Right.
Really helpful for us.
Yeah, really helpful. Okay. Right.
Thank you so much,
Again.
guys.
Yeah. Okay. Thank you, admin.
Yeah.
Well, guys, I think it's time to say goodbye. Thank you very much for coming. The live session will still be available here, maybe in the next 1 hour. So after that, I will delete all the accounts. So if you want to practice, uh, just uh, just do it. Okay. Thank you. And have a nice day.